Prime Factorization, Prime and Composite. Prime numbers are divisible by 1 and itself. Let's look at some examples of primes. You don't have this on your workbook, but this is a little table here. We're going to do something called Aristosthenes' sieve. And what it does is it allows us a really quick way to find all the primes. And so basically what we're going to do is we're going to start with our first numbers that are not primes. Everything's a multiple of 1, but then we go to 2. Now 2 is a prime, but everything that's a multiple of 2 would not be. So that means that everything that's a multiple of 2 I can cross off. And that's going to be all even numbers. And you can see some nice patterns here emerging from this. So those are all my multiples of 2, and I just cross those all off. Now let's go to multiples of 3. Now we got 3, 6, 9's a multiple of 3, and then we get this really cool pattern. If I look here on the diagonal, those are all multiples of 3. So that means that I can just go on the diagonals to cross off my multiples of 3. Now 3 is a prime number, but 12 and 21 aren't. Now I go to my next 3, which would be 6 here, and we go on the diagonal for that, and I can cross all those off. Those are multiples of 3. We go to 9. Again, I can cross all those off on the diagonal because those are all multiples of 3. Now I'm getting it gets a little bit harder to do here, but we can go to 30, and all those that are in diagonal with 30 are going to be multiples of 3. And then 60, again, all those will be multiples of 3. And then to 90, and we get 90 and 99. So then I can go to 5, all the multiples of 5. Those will be the ones that end in 5, and all the ones that end in 0. Now look at our next prime number that actually shows up is 7. So we need to go through and make sure all our multiples are 7. So this gets a little bit harder. I need to count here. So I got next multiple of 7 would be 14, and then from 14 I go 3 times 7 would be 21. 4 times 7 would be 28. It's already marked off. And then from 4 we go 5 times 7, which would be 45. It's already marked off. 6 times 7 would be 48. 7 times 7 is 49. That one's not marked off, so we'll cross it off. And then 8 times 7 would be 56. So it's gone. 9 times 7 would be 63. And it's already crossed off. And then 10 times 7, that's already crossed off. And 11 times 7 would be 77, so we can mark that off. And 12 times 7 would be 1, 2, 3, 4, 5, 6, 7, 84. We're already crossed off. Okay, so from 7, my next one is going to be 11. So we know that those will be 2 times 11 is 22. It actually gives us this really interesting pattern. If you look down here, these are all my multiples of 11. Kind of cool. And then our next one that shows up is 13, and we'll have all of those. So that what leaves us now are prime numbers. We have 1 we do not consider to be a prime number, by the way. We have 2, 3, 5, 7. Then we have 11, 13, 17, 19, and then 23, and 29, 31, 37, and then 41, 43, 47, and then 53, 59, 61, 67, 71, 73, 79, 83, 89, 91, and 97. You want to get kind of used to these numbers, get familiar with them, because you're going to need to be able to recognize which ones are prime numbers. Composite numbers are divisible by more than one in itself. They're usually, they'll be our numbers like, say, 4, where you have factors that are 2, like 2 times 2, which is more than just 1 in itself. So we also have 1 times 4. So there's multiple ways of getting composite numbers. So we want to think about those as being something that we can multiply multiple different ways. So that's how we tell what composite numbers are. So let's take a look at our examples here. Now our first one here is asking if it's 89 is prime or composite. Well, 89, if we take our look at our list again of prime numbers, 89 is in our list, so it's a prime number. But I can also check it by doing some division. I can't divide 89 by 2 because it's not going to come out evenly. If I try to divide it by 3, so 3 goes into 8 2 times, which gives us 6, 29. 3 doesn't go into 29 evenly, so that doesn't work. And I could try 5, but it doesn't end in 5. It's just not going to be possible to come up with a number besides 1 and 89 to do this one. Now let's look at example 2, prime or composite. We have 147. So it doesn't end in a number that's divisible by 2 because it's not even. So let's try 3. So 3 goes into 14 4 times. 3 times 4 is 12. 4 minus 2 would be 2. Oh, 3 goes into 27 9 times. So since 3 times 49 is 147, that's going to be a composite number. If I can find anything that goes into the number besides 1 in itself, it's going to be composite.